SENX4, Spearheading Superresolution. Sentinel-2 images like you've never seen before. A dramatic evacuation from the Hamid Karzai International Airport at Kabul took place as the Taliban spread quickly through Afghanistan in August 2021. With Sentinel-2 images at 10 meters resolution, the evacuation apron appears excessively blurry. After we apply our super resolution technique, the new images at 2.5 meters reveal a new scenario. Now we can easily detect aircraft landed. Not only that, the improvement is enough to identify the type of aircraft, which can provide invaluable information for decision makers.
Super resolution consists in improve or increasing the spatial resolution of any image. If you take a pixel of any grayscale image, you can split this pixel and then you can complete these four values based on those around it. In the resulting image, you can see objects that are not seen in original image.
Sentinel-2 satellites of the Copernicus program provide imagery of the whole world at no cost to the users. They offer unparalleled operational capacity, covering the whole world every 5 days and capturing information from a wide section of the spectrum, offering 12 spectral channels. The spatial resolution is 10 meters, which is good for its original purpose, but improving the resolution 4 times down to 2.5 meters greatly expands its applicable scenarios.
Applications such as accurately measuring and retrieving glaciers, increasing the resolution to effectively monitor critical infrastructure such as airports in a scenario of an evacuation, measuring agricultural plots to support decision makers implementing the Common Agricultural Policy, or accurately determining the extent of a natural disaster are just examples of areas in which super resolution of Sentinel-2 can have a high impact. The main challenges that we face today in the world of Earth observation are mostly related to the amount of data that we are able to acquire. Artificial intelligence is a game changer in how we approach Earth observation data processing. Thanks to machine learning techniques, we have the capacity to process amounts of data that before we couldn't, and to process data in ways that before it was impossible.
Deep neural networks are able to learn from existing data, finding relationships in the input that often escape the capacity of humans to analyze data.
Our baseline was the bicubic interpolation, and this method only takes in account the pixels close to the value that we want to interpolate, and this produces a blur effect. Then we try to solve this problem using deep learning. When we work with deep learning, we need to pair of images with low resolution and high resolution images. And we train a network that is capable to learn how to translate a low resolution image to high resolution image.
In order to measure our results, we used widely accepted metrics in image analysis, such as PSNR and the SSIM. These metrics indicate the similarity to a target high-resolution image. Comparing with bicubic as a baseline, we have achieved a substantial improvement in the metrics that translates into a more defined, clear and reality-adjusted image. We have achieved successful super resolution all the way down to 2.5 meters, effectively making the spatial resolution of Sentinel-2 4 times better. The promising results obtained indicate that the limits of super resolution have not been reached yet.
We have implemented and continue to improve innovation ecosystem, creating dynamics that favor the identification of value and corporate cultural change.
This enabling technology constitutes a clear example of the permanent commitment of Tracasa to research, development and innovation, 3 elements strongly rooted in the DNA of our company.